Well, we have the great privilege of again having Glen with us today, and we're going to continue on with part 3 of our episodes about the observer. And when Glen and I left off last time, we were talking about Dave Ackley's demon horde sort, which is robust computing, as opposed to computing that's based on correctness and efficiency, which is like the old-fashioned computing. And I was telling Glen just before we got on that when I think about the correctness and efficiency model, it reminds me a little bit about Jordan Peterson talking about rigidified order and how important it is when order gets too rigid that you bring in some of the chaos. Now, you don't want to go over into complete unmitigated chaos, but when Ackley is talking about this robust computing, it seems to me he's talking about that sweet spot where you aim high, but you're going to miss your aim, but you're always going to recalibrate and keep going because you're just trying to make some forward movement, and all the learning takes place in the failure and in the mistakes. And so when we left off, Glen, you were talking about how sometimes you could go in and blow away a third of the resource in that panel, and it would still build itself back up again. At the beginning, when it starts building back up again, the results are going to be pretty high error.
Right.
But over time, it's going to get back to being solid again. And so I thought that was really fascinating because it seems so human.
Well, exactly. I mean, you look at society and you can have a centrally planned economy, society, or you can have more of a diverse society, a more distributed intelligence, kind of a free market kind of thing. I mean, this is exactly what's happening. Is what he's saying is to have a robust computational system, it's better to not have a single correct always, kind of central planning, but let it chaos go. And as long as all of the individual elements are obeying a certain set of rules and talking to each other, a distributed system like that is much more robust in the face of adverse events. And we look at an economy or society, it's the same thing. That's the nice thing about capitalism versus some of the central planning is it's chaotic, it's not efficient, but it's robust in the presence of threats and disruptions. But we'll come back to this because the metaphor just keeps going.
Okay.
There was a comment in the comment section which raised a couple of points that I thought about, and I thought maybe I should just quickly touch back. And one was on the diagram from now the choice diagrams into the future. So if I can share, I will. So remember this this drawing.
Yes.
And the question was what it actually represents. And I never thought about it, but the commenter was talking about a past to future. So it represented like a tree with roots into the past and branches into the future. And once I looked at it that way, it's like I can't unsee it. So hat tip to your commenter. And he also raised a question about the universal observer. And I wanted to share a different screen on that one. And that is the Matt at PBS Spacetime did a really wonderful YouTube episode on exactly this. And it's going to be in the reference. So if anyone, I would recommend people look at it. But I'll want to play a section for about 3 minutes. And that will hopefully answer some questions.
So we're going to share this PBS thing here and start at minute 10. And I always have to back it back up.
That is consistent with the questions asked of it by all observers. The universe, according to Wheeler, was a giant closed, self-excited circuit. The relationship between the observer, us, and the observed, the universe, brought both into existence. Take this yet further and you have a version of the strong anthropic principle. The only reality that can exist is the one that can have observers whose questions can make that reality real. Wheeler called this the participatory universe. He symbolized his idea with a sketch of a giant U. On one side of the U we have the Big Bang. As the universe expands, the line of the U gets thicker until we reach the present day, the other side of the U. An eyeball here symbolizes the observer. All the astronomers with their telescopes and observatories are aimed back at the Big Bang. Their observations now cause the Big Bang then. Well, sort of. As Wheeler once wrote, the past has no existence except as it is recorded in the present. Only the self-consistent now can have a real existence. As I warned, this all sounds a little bit mystical. Let me be clear though, Wheeler wasn't saying that conscious minds have direct power over reality, as claimed by some of the worst practitioners of quantum woo. But the role of consciousness was something that Wheeler really struggled with. He said, about no feature of it from bit do I feel less comfortable than whose bit. After all, information implies a thing to know that information. But non-conscious entities can, in a sense, know something if information of that something is recorded inside their being somehow. He also once wrote that it was not consciousness, but the distinction between the probe and the probed that was central to the act of observation. So observation could well be code for interaction, in which every time two particles bump together and become entangled, we have an act of measurement. If this all seems a little vague and wishy-washy, it's because it is. Wheeler was still obsessively thinking and writing about and trying to solidify these ideas until his death in 2008. In John Archibald Wheeler's version of an informational universe, he felt that the information, the bits, resided in the answers elicited by acts of observation. It appears to pull the comforting ground of realism from under our feet. But others have taken Wheeler's ideas and put them back on firm ground. It's possible to think of a universe as being informational without altogether giving up on realism. In the broad category of participatory realism, we have things like quantum Bayesianism and relational quantum mechanics, in which the universe emerges from the information that some set of real entities have about each other. Crucially, these acknowledge the importance of the observer in defining the observed, while still allowing that there's some kind of substrate to reality. We'll talk more about these ideas soon in our long quest to find that substrate. And to do that, we just need to keep asking the right questions of a participatory spacetime. Hey everyone.
Okay.
So I have some questions.
Okay, go for it.
This is the second or third time I've watched that. He said that John Wheeler's biggest question was whose bit? Well, now what did that mean?
Well, I take it as if the world is full of multiple observers, then which observer is collapsing the wave function to turn the bit of information into some physical reality? That gets back to some of the paradoxes that come out of measurement in quantum mechanics. Is if multiple observers are looking at different parts of an entangled system, and you take that notion of collapsing the wave function seriously, then who gets to choose how the wave function collapses? And so whose reality are you creating by doing the observation?
Well, is there an implication there that if you have multiple observers on this plane, that there has to be some level above that has some organizing principle that prioritizes one observer over another observer?
You're getting it. One way you can look at the free will theorems is what they're saying is it doesn't matter who goes first. if multiple observers are looking at an entangled system, the outcome of the experiment is not tied to who goes first. So does that mean the quantum system sort of had a mind of its own, since the outcome was independent? So you can think about that, but what I pick up from it, and one of the things that really struck me back in years ago when I was thinking about the Maxwell's demon, is Wheeler never asked about what the nature of the observer was. He just took it as a given. He treated it as a demon, a thing that was there, but never asked about the structure of the observer to begin with. And that's my suggestion from the first couple videos, is that if you stop looking at the universe in terms of information that becomes real after the process of observation, you instead focus on what the observer is and just let the universe be. So the universe is already there, and we don't create it as the observer. So I tend to look at the observer, and then I see computation as the fundamental aspect in which information then becomes downstream or a consequence of computation. So this kind of frees up the participatory universe, because the observer is now separate. The universe is still there, whether we look at it or not, whether we are around.
So that answers Einstein's question.
Sort of, but it does present a conundrum, because the observer can't be quantum mechanical. That comes out of Schrodinger's cat and Wigner's friend paradoxes. Whoever or wherever the observer is, it's not quantum mechanical. It has to be something above or separate from. And that would tend to imply that there's a universe of quantum mechanics, but then there's a universe of agents, of people, things that are capable of observing, making choices, and then acting back on the substrate of the quantum mechanical universe. So I think this kind of pushes you up into Wolfgang Smith's line of thinking.
That's what I was going to say.
Yeah. So
think that way. Yeah.
So I'm not sure I follow.
Particularly, there's two parts of that, particularly that align with his thinking. And the first one is when you talked about there actually is a universe. There actually are things. There are apples and computer mouses and computer chips, and Glen is sitting there and I'm sitting here, and we actually exist, and people who observe, other people who observe us are actually seeing something when they look at us, and we actually have certain colors associated with our skin and our hair and our teeth and our fingernails and all of that and that actually exists, and those things are sensed by another person's visual apparatus. Those are all real things. It's not just an illusion. It's not just mental. It's not just electromagnetic waves or whatever. So that's the first thing, where and he gets that from James Gibson's work on the ecology of perception, which once I started digging into that, I thought, man, that stuff is deep. So then the other way is this idea of the vertical causation, that if you could think of the quantum world as being all on the horizontal, and so there has to be something vertical to the quantum world that brings it instantiates it. So that doesn't necessarily mean that it has to go all the way up to the highest, but that at each level there is some sort of observational thing going on. So I mean, like if you look at Schrodinger's cat, there's a lot of different levels in that. And then Wigner's friend puts a lot of different levels above that, right? So each time somebody gets entangled into that system, or some entity gets entangled into that system, it's another vertical relationship.
Right. Yeah. So what you end up with layers going up vertically.
Yeah.
With quantum mechanics being the ground state, so to speak, of the universe, the laws of physics. but out of that, other layers can come arise. And
well, but so this is this is another thing though that's taken me a while to grasp, and it may disagree with your thinking, but I think it would agree with Wolfgang Smith's thinking, and that is that it's not that reality arises out of the quantum, but that reality consists of the quantum. So an apple doesn't arise out of all the parts. Mm-hmm. An apple is an apple, but if you take an apple all apart, when you get down to the bottom, you're going to get down to the quantum level.
Right.
So the whole exists before the parts, where a typical physicist, astrophysicist, whatever, talking about the Big Bang and the beginning of the universe would say that everything started out as particles and eventually made its way up into things. But Wolfgang Smith would say that reality can't function that way, because there has to be at least a vision of the wholeness before the wholeness can be there. And it has to be like a design, or like an artist's work. Like my work might consist of many, many, many different brush strokes and little bits of paint and ways in which the brush moved on the canvas and all of that kind of thing. But that is not what created the painting. The painting was up here first before it got on the paper. Yeah. Like you talk about with the music being a symphony of choices over time, a computational thing. But the music was here before it got on the paper.
Exactly. So we'll keep coming back to this, I think. But hopefully I've covered the points from before. So I'll get back to the demon horde sort and start off from there. Because I think it gets back to exactly what we're talking about. What I liked about the demon horde sort is that the computation is actually separate from the underlying physical hardware. So you can damage the physical hardware and the computation still goes on. And so to me, that's an example of how possibly, I'm not saying that this is how it works, but it's a example in life experience where computation is disconnected, separate from the underlying structure. So imagine if you go into quantum mechanics and you want to build this thing called the observer. We know it can't be quantum mechanical by itself, but if you look at the observer as underlying quantum mechanical structure, but yet something else going on sitting on top of the quantum mechanics, which is causally disconnected from it, then the quantum mechanical world can still entangle and do all its stuff. But like the cellular automata still function and still compute and still go about their life, regardless of what's happening underneath. There's a separation going on, or an isolation. I think if you can do that mathematically for quantum mechanics to a classical system, then you've got your observer. And then I think a lot of physics will have to fall out from that easily.
Well, how would you go about that?
Well, I don't know. I would start by being about 40 years younger and a turbo nerd that I used to be, and then dive into it.
Well, I mean, let's say you had an assistant who was a math genius and they were 40 years younger than you, where would you tell them to start? I mean,
how about I get back to you in 2 or 3 months?
Okay, I'm sorry.
No, I've thought about it, but I'm just saying, we'll just say, take it as a premise right now, if you can do it. Okay, I'm not saying that you can. So
let's restate it. If you can find a way to mathematically show that so maybe I misunderstood. If you can mathematically show that it's possible for the underlying quantum substrate to be causally disconnected from the the layer above.
Right.
What would that layer be?
I don't know, but what it's trying to say is that it breaks Wigner's friends problem. There's a point where entanglement doesn't affect the next layer of observation up.
If there is a point where the entanglement does not affect the next layer up,
right,
then that would solve the observer problem?
Yes, in physics.
Okay.
But if you can, but if it does work, then that would suggest that computation is fundamental in the sense of sequence of choices guided by a set of rules.
Okay, so if it doesn't work, then computation is fundamental?
If it does, if you can do it, then I can say computation is fundamental.
If you can do it.
Yes.
Okay.
Then, but I think physics has to face it. It's the question of the observer is probably more important than things like the anthropic principle. So, I'll take a deep breath.
You're doing great. And I mean, I get excited, so I probably jump in too much, but.
Well, one of the things that I find get so excited about, and we're going to keep going, I think, on this one, is if language, I mean, if computation is fundamental, then you get language as being fundamental as well. Language and computation come together. It's a nice pair. You can't break them. And I think from a lot of philosophical points of view, I think that would excite a lot of people.
Well, I mean, that totally makes sense because even on the computer level, the way that we make computers operate is with a language. And so the two have to go together, right?
So let's see.
Come to think of it, every place that you have a language, you have computation.
And vice versa.
Because mathematics is a language, and mathematics, there's a lot of computation, and music is a language, and there's a lot of computation in music. And with just the language that we use, all of the syntactical and semantic aspects of language have to be very computational. I was thinking about this yesterday when I was watching a conversation between two people, and how as they're speaking, each of them is saying sometimes new things that they've never even thought about before, but they're saying it now for the first time. And yet there's a way in which they can connect up the ideas and the words and the grammar and relate it to what the other person is saying. And that's all happening in real time. And that's a computational function.
Bingo. That's exactly where we're headed next. So I'll introduce your long suffering and patient listeners to Robodog.
Oh, wow.
and what I'm trying to do, I remember Mark Solms made the great comment that in order to understand something, he has to build something, and I'm exactly that same way. I kind of work and think with my hands. So if I want to understand or learn, I build something to go with it. So Robodog is a project that I'm going to use to explore language in learning systems in robotics. And I'll show my screen real quick. And then so in robotics, you can go out and get kits like this, that they're undercarriage kits. And this one comes with 4 motors and 4 wheels. And how you steer a system like this is by differentially speeding up or slowing down the 4 different motors. So if you want to turn left, then the motors on the right go faster and so forth. So hopefully that makes sense. Now, how this is actually implemented in a robot is you'll have some kind of vision system, a camera, could be very simple Raspberry Pi kind of setup. then that inputs data of what's ahead, what's the goal, what's the target, what are the obstacles. Then you have a central processor, which can do a lot of heavy duty floating point arithmetic. You have these control algorithms. It generates output and then goes to the 4 motor controllers. There'll be a motor controller for each one of these motors. And so there's kind of a central planning process here that controls the motors based on the goals and everything else. But there's another way to do it, which intrigues me. And that's if you think about computation as a language. Now, what if the motor controllers on each of these 4 motors had the ability to talk to each other? So instead of having a central algorithm in floating point, you just gave some bare information to the 4 motors and let them have a conversation between themselves as to what they're going to do. And this is exactly how a collective consciousness or collective intelligence often works. Now, if you go back to the demon horde sort, I think is a good teaching moment to look at the difference between Wolfram and Michael Levin. The simulation in the demon horde sort, basically the program running the simulation is in one place in memory. What you're seeing displayed is just a database. They're all passive entries that keep track of what's at different places, but the actual intelligence is a program somewhere else. So that's kind of the Wolfram paradigm where the rule set is out here, but the structure of all the connections is being operated on by something outside. But if you look at how cells work in the embryo, there is no over-intelligence. The cells are each intelligent or have the program in themselves. And what happens is out of like a conversation they're having amongst themselves. So if you took Dave Ackley's simulation and replaced all the cells in the array with computer chips that were all tiled together, and so each computer chip was running sufficient program so that the cellular automata would float around and float from one cell to the next. But in that case, the intelligence is in the chips rather than outside. So we have 2 different paradigms, and I think I kind of tend towards the Michael Levin one, where you have a group consciousness arises out of a conversation. And it comes back again to this computation and language come together. So if you have a group intelligence or distributed intelligence, then you can imagine a conversation. So that's the plan for the next few months, is to work on this. And I think it can be done. And what's exciting about this kind of control as a conversation is it's adaptable. I live in farm country, there's farm fields all around me. I'm really intrigued by what it would take robotically as just a problem to replace a field worker out picking crops. This is a massively huge problem conceptually, because once a robot leaves the factory floor and goes out to the field, everything is different. Every plant is different, the rows are different, the mud. So you need a system that can constantly adapt moment by moment to whatever is happening in front of it. A centrally planned thinking process with an algorithm running in a Pentium running gigahertz is stuck. But if you have a conversation between the motors, that's adaptable. And if I can do it, I would create a system that now is adaptable by conversation. And it gets even better because when you have a conversation, things can grow, things can change on a moment by moment basis. And I wanted to.
Well, before we move on, can I ask a question about the, if we just take it back down to the demon horde sort level and say that all of those, would all of them be chips or just the dregs or just res?
You just the blank array. instead of a bunch of cells as data, points in a memory array, each of those cells is actually a little chip, and they're all wired together.
So the whole array is just chips. So
Yes.
you don't have the little drag moving around and doing things.
No.
It's just that the computer chips are all connected together, and so they can communicate together. But each of them still has a process that it's working on.
Internally, yes.
Okay. And then they're talking to each other about their processes. And
well, they talk to each other just enough so like consider a tiling element. You tile the floor, and each chip is a square, and it has 4 leads going out each of the sides. And when you tile chips together, now the 2 chips, their leads line up, so this one can talk to that one and that one. And they just have to know enough how to talk to each other, and that's it. The cellular automata is now a program that moves itself from one chip to the next.
Well, so now let's bring it down to the Robodog level. You have these 4 motors, and each of them is its own little chip or its own little computational system. They still need to have a common aim.
Yeah, somewhere up there's a layer that gives them a general idea of what they have to do.
Otherwise, I mean, one guy could say, well, I think we should go faster here. And the other guy says, well, I think we should go slower here. And then you're just all jammed up, right?
Right. And so you know what comes out of that? The robot will have to be right or left-handed. Somebody has to take the lead. There'll be a lead motor, and that will be the one that decides what the other ones will do.
Hierarchy.
Yes.
So really, that's really interesting. So handedness, which is built right into the very lowest level of cells and of living organisms, that is already hierarchical right there.
Yeah. Yeah. That's the kind of things I get excited about when I think this way. It's like, wow. So maybe there's something with right and left brain that's there. But as soon as you think in terms of computation, then you get to play with languages as the counterpart. And the fun thing is how do you take some kind of control algorithm written in C, running on a floating point processor, and turn it into a conversation? And that's where, I get really excited about how that maps to how we work. But just so people don't think I'm totally crazy, if they haven't already, I'm going to share my screen again.
You're about the furthest from crazy of anybody I've ever met, Glenn.
Here we go. There is a language. Can you see it? It's called Forth.
Yes, I read this article.
And just if you're younger than 50 years old, you might not know it. But I learned it back at the beginning of the 80s, before I actually learned C. And it's amazing. My first robot arm program, which I ever wrote, was in my microprocessor class. And I used Forth to write the program for the robot arm. And I've been hooked on it ever since. It's not a language you would ever write any kind of Windows application, and it's really grunt level. But I just wanted, there's a thing here, it highlights, it says when your Forth code is right, it reads just like a natural language sentence, but getting there involves a bit of puzzle solving. That's one of the jokes. If you're clever about how you define words in Forth, when you read your source code, it will sound like you're talking like Yoda. So if you want to be a Forth programmer, you just talk like Yoda and you're right there. But it's a very verbal style of programming, and it's exactly how we talk to each other. And so, but the other nice thing, features, or many nice features, Forth is its own compiler. So you talk to Forth, and it compiles what you just basically told it. So there is no need for IDEs, compiler tools. You can plug a terminal into a Forth system and start typing, and it will just read it in, compile it, and include it. And it also fits in like a few K of memory. So it's tiny. You can embed it everywhere. And I've used it in some of FPGA designs I've done in the past that require a little embedded processor inside to keep all for housekeeping. I use a stack machine like this with a little Forth-like language. So
as I understand it, the reason that it requires very little memory is that you have to keep it relatively clean and tidy because everything builds on everything else. So if you accidentally left some garbage in there and haven't cleaned it out, then that could corrupt your code going forward.
It blows up, yeah. So but the other nice thing about Forth is a Forth program can rewrite its own code on the fly while it's running. In fact, the Forth system can rewrite somebody else's code, and one system can read the dictionary words from one Forth system into its own and then learn that way. So one of the features that I finally grokked about Forth is everyone typically refers to it as a language, but it's actually a context-free grammar. And I know that's the next level up from state machines. The corresponding computational structure to a context-free grammar is called a push-down automata, which is actually what Forth runs on, is a stack machine. There is no registers. It's if anyone remembers the old HP calculators with the reverse Polish, that's a hint of it.
Well,
so,
could you just explain a little bit about context-free grammar and push-down automata?
I can try. I'll give you some examples. You might, if you're programming, you're doing a calculator, you'll type 3 + 4 =. But in Forth, you go 3, 4 plus. So every time you put a number in, it pushes it on a stack, and that stack keeps going down. You know, like dishes at the cafeteria. You take the dish off, and the spring keeps pushing things up. So whatever you push onto the stack, and then if you throw an operator, it'll operate on whatever the top of the stack is, and leave whatever you've just done on the stack. So it's kind of.
So if it's 3, 4 plus, it would be 7. If it's 3, 4 minus, it would be -1.
-1, yeah. So I don't want to dig into it too deep.
No, so and it's called context-free grammar because a
grammar tells you the rules to build a language. So as we build it up, there's an alphabet, then there's a sentences or words, you might say, that you can build as strings of symbols from the alphabet. And then the set of all valid strings is then the language. And then the grammar is the set of rules which tell you how to build a language up. So you might say Hamlet would be, you could say if Hamlet was a language, then all the sentences that are in Hamlet are valid English sentences. But a grammar says, well, here's how you build a valid English sentence. So it lets you keep going. And because Forth is kind of a grammar rather than a language, it grows. You can keep adding to it. You can redefine words as long as the structures you keep building follow the rules of the grammar. You can keep just getting bigger and bigger.
But what makes it context-free? I guess that's my question.
I guess I would have to dig out my textbook.
Oh, okay. Okay,
yeah.
Never mind. I thought maybe.
Okay, Google context-free if you're really a masochistic person, and go to the Wikipedia page.
Okay.
But then there's another layer up, which is what I'm working on with Robodog, and they're called indexed grammars. And the corresponding structures for those are nested push-down automata. And I'm not sure I've communicated, but one of the exciting things about computation is there's a whole menagerie of grammars and languages and computational structures that line up with different levels. And it just gets, I don't know, I get excited. But you can break down language into threads, you might say. And corresponding to each of the threads in natural language is one of the possibilities. Better start off. Index grammars are when you look at an input stream that has multiple threads, each obeying different grammars. And so each of the threads initiates a different layer in the computation. So you can get layers of computation interacting with each other, and it shows up in layers in the multiple grammars happening at the same time. So it's a candidate for natural language processing. So
yeah, I mean, I can totally see that.
Okay, so
just from personal experience, I can see that.
I'm not going to make something for natural language processing for humans, but I thought, well, if I can get the natural language working at the level of dog communication, okay, that's a good toy model to work with. So that's kind of a silly thing, but that's where I'm at. But I'm also noticing this pattern. It's not just language and computational system, and then conversations as a collective computation, but that there's layers to grammars that you can look at. There's in the case of Robodog, there's basically the math level, plus minus, shift right, logic or. And then there's the next layer up, which is tending to be the task layer. It's predominantly verbs, do, go, turn left. And then there's a layer above that, which is going to be the learning or the adaptation. And that grammar is going to be more faster, slower, a little bit, to be more adverb kind of. Is that making sense?
Yeah.
And so you can have nested computational structures.
So it gets more nuanced as it goes up the layers.
And so that's what I'm playing with, and I believe it will work. And that's how I get this. I talk about how language is actually like the symphony, where there's different levels of our language, natural language, and each one is like an instrument in a symphony or orchestra. And what we call natural language is actually the result of a whole different layers happening at one time. And you can take this farther if the motor drive can be instantiated as a conversation. Maybe there's other layers of conversation going on. And this seems like it might tie into Mark Solms is talking about layers of consciousness or layers of intelligence in the human processing.
Well, that was what jumped into my mind when you first started talking about the indexed grammars. Was there are times in my life when there's been a collision inside my brain of many different threads coming together that might be a memory of a certain time period in my life that collided with the memory of another time period in my life, and maybe both of them had a different emotional valence, and then it collided with the thoughts that I was having about some other thing or something I saw in a movie or a piece of music or a certain fragrance, and all these things collide at one time. And that's where these like huge insights come from sometimes, right? When all these threads come together, it's like they're different grammars in a sense, because they're all, each of them, you showed the upside down tree and the right side up tree. It's almost like each of them is one of those trees. It has all its roots in the past, and then they all come together to form a new thing in the now.
Well, that was one of my analogies from before, is rather than a tree going up, it's more of a vine. And if you put a bunch of trees together of possibilities, then all of these future pathways can actually entangle and then form a tapestry.
Yeah. Yeah, it's beautiful.
And in terms of computation and conversation, I think it might help. One of the things I've played with was if I went out to the field and I was trying to tell someone, well, how to do something, I would instruct them. I'd say, okay, go down here, do this, put that in the box. And I realized along the way that when we tell someone, instruct someone how to do a task successfully, we've actually just done a fourth program. If you do your programming in fourth and you're clever, it will sound exactly like you're talking to somebody to tell them how to do something. And I think a lot of people don't look at just offering the instruction on how to wash dishes, how to set the table. You're actually programming somebody or offering when you do that. And then if you look at training, work out for track, no, do this faster. Try learning a skill. There's a different vocabulary of better, faster, slower, whatever I'm trying to say. But that same vocabulary for training is the vocabulary a collective conversation would use if it was adjusting or adapting on a moment by moment basis to changing circumstances. And now you open the door for your system to learn. I don't know if that you see that.
It must work that way with our bodies too. When the autonomic nervous system and the like, if you're out walking, for example, your autonomic nervous system is operating your heart and lungs and all that stuff, but your legs there's a certain intentionality in that, the way you're moving your legs. But then you hit something that's not level, then what's it called? The proprionic system, whatever it is that allows you to balance, and that sort of internal gyroscope and all of your senses become more aware. Everything kicks in at one time when you hit something unlevel, and then they all have to work together, right?
Well, yeah, that's one of the interesting sidebars to this robotics thing I'm working on, is that you would think that a field worker would be on the bottom end of skilled or semi-skilled labor. And you would think that they should be some of the first people to be replaced by robots. But in fact, they will probably never be replaced by robots. On the other hand, the first labor force to be replaced by robots was the auto industry, the high end. So we tend to think of working in the fields as some kind of a menial task that doesn't deserve a very good pay. But if you take the notion, can I replace this task with a robot as a metric for how difficult the task really is, then that would suggest what the field worker is doing is actually far more complex than what the auto worker was doing. And then you think about, well, where does that complexity lie? And I think Silicon Valley is really bad for this. I've noticed as an engineer, there's quite a prejudice against manual labor, people who work with their hands. But there's a tremendous amount of intelligence that just goes into manual dexterity. That if you're going to make a robot that will work in the field, you'll have to reproduce that intelligence as well as the upper level of intelligence that we usually take for granted. So if you watch field workers, or you've done the work yourself, it's amazing how quick they work. And a lot of them, if you watch, they don't even watch what they're doing. They work by feel. They don't use clippers like a lot of the robotic pickers do. They use knives. Trying to reproduce what you're seeing in a field worker is beyond doable right now with technology.
Well, sure. But the manual dexterity of even being able to feel whether or not the produce is ripe, properly feel it without damaging it.
Right.
It's going to be really hard for robots to do that. By the way, I have to put in a plug for moms. Moms are even lower on the scale than field workers because they don't get paid. But try replacing a mom with a robot.
Yeah, it won't happen. Actually, there's a lot of jobs that will never be. All of the field jobs like logging, construction, there's so many jobs that will never be replaced by robotics because a human could do so much. But it comes back to the fact that I think there's layers of intelligence and computation going on in our bodies and our humans that actually happen below the conscious level. And a lot of people don't think about it. I think that's why I like Mark Solms. He seems in his thinking, he's aware that there's these layers of intelligence and some people might call it muscle memory that's going on underneath, and we're not necessarily aware of it, but yet it's there and it's quite powerful.
Yeah. So anyway, I'm sorry I interrupted you. You were kind of on a roll there. You were talking about how grammars have layers.
Yeah. So I think I'm finally at the end of the trail here. That we start with computation and the observer, and we've ended up with robots having to be right or left-handed, and that language and learning and adaptation all are intertwined together.
Yep.
And so if we want language and learning, then our language must be truthful. So there's it's one thing I take away is that if computation is fundamental, then there has to be, like they say, a covenant between truth and language.
Oh, I like that.
So, all right.
Do you want to delve a little bit more deeply into that? A covenant between truth and language?
Well,
I mean, how many different levels do you see that operating?
At the bottom level, it just means Darwin wins. Systems that are not faithful to how the laws of physics work. I mean, you might think you can fly, but laws of physics say you're not. So our internal rule sets at all levels have adjusted themselves to physical reality. The laws of physics are embedded in a lot of levels that we're unconscious of. I think where it becomes important is if we realize that we are, as humans, basically agents that form together to create a greater collective consciousness. That we are creating societies. We're part of something bigger than each of us. Does that make sense? And
well,
so
it makes me think of Mary Cohen's sign off.
Yeah.
When she would sign off at the end of one of her videos before she passed away, she would always say, treat yourself as though you're someone you are responsible for caring for, because you are responsible, right. And I am too. And together we are making the world.
Yes, I noticed that the last week. That was.
Yeah. So you are responsible and I am too. And together we are making the world. And what we're really responsible to is lining up with reality. Sounds like.
Right. So, you go back to Cesar Hidalgo and his notion of trust networks, that he's thinking in terms of economic models, and if a bunch of people come together, you can form a collective distributed intelligence, which can now handle bigger problems than any individual by themselves could tackle. So, Milton Friedman's concept of a pencil, he said, no one knows how to make a pencil. And then he went through all of the different steps that, from wood to the metals, and all of this pyramid of labor and intelligence and individuals and skill sets that have to come together just to make one pencil. And what Cesar Hidalgo would say is, before the pyramid can form of talents and abilities and resources, there has to be a trust network between all the individuals that allow them to all put together their combined effort. And how do you get a trust network that's big? Well, religion, culture, tradition. Certain cultures lend themselves to larger trust networks. If you go into the Islamic world, especially the Middle East and other areas, you have cultures which are very family or clan oriented. Whereas not necessarily, but if you get into the more Christian Western European, trust networks can span continents and generations. So there's we form collective consciousness, and if it's healthy, it's the Holy Spirit. But there are unholy spirits as well that we can also become parts of, I think. And so it's important that truth and language is there, because if our rule set is based on a certain assumptions, and if our rule set is fed false information, you can get that rule set to take you to places which are not desirable. Which is why I think Jordan Peterson intuitively senses that Bill 16 was a hill to die on. Because once you allow a central, a regulated or restricted language, then free conversation can't happen. And that destroys the collective intelligence that happens when groups can talk to each other freely.
Yeah, and the reason he stuck to that one was that was not only telling you what you couldn't say, but it was telling you what you must say.
Must say, well, yeah.
And if they're telling you what you must say, then what they're really doing is driving out the language that you already have and replacing it with another language, which, I mean, that's 1984 all over again, right? Newspeak and all of that stuff. And we have seen that happen increasingly, especially over the last 30 years, but the last 5 years, it's just been catapulting forward to where in any conversation, if you're not very cautious about how you speak and use the appropriate language, you can get yourself into all kinds of major trouble. But what that's doing is driving out all of the conversations that might actually solve the problems that we have and might actually unite people rather than dividing us. So
I know. Well, I went through a textbook a long time ago. It was called Computational Collective Intelligence. And it dealt with the distributed systems, of computation, and precisely this notion of letting a collective kind of conversation happen. And so you can show actually, apparently mathematically, according to this author, that collective solutions where you let the decision-making happen at the level where the input-output is, statistically, on average, will always get you better solutions than having a centrally planned or centrally controlled algorithm trying to run everything. And the classic example that came out of the textbook was the bakeries. You have a large metropolitan community, and the bakeries, all the donut shops, they just make what donuts or pastries or bread they need for the customers right in their area, and they have a sense for what it is. And that would seem chaotic. Our masters of smart decided, well, maybe we should have a department of bakeries, and so we can really control all the individual bakeries, and we can save waste at the community level. People won't be throwing waste. But then what happens? The department of bakery ends up say, well, you make 100 donuts or you make this or that, and you end up throwing away more, which is the Soviet model, is what happened in the Soviet Union. So I think there's people sometimes, maybe it's a psychological, they want control, they want to figure they have a system. They're afraid of a little chaos, but chaos is adaptable, chaos is changeable. It might not be the most efficient, but it's the most robust system. And on average, it will do a better job in terms of arriving at decisions than a centrally controlled system. I think if there's...
Well, and the centrally controlled system cannot function over long periods of time without coercion. It's just not possible.
No, and then there's a lot more problems. I don't want to, issues that come up, but like in Dave Ackley's work with indefinitely scalable. If you want to build a computer, it can keep growing as you tack tiles onto it. And that's one of the cool things. A fourth program could actually be programmed to add tiles to itself and grow. So now I have a computer system and a language that will actually be able to build itself mechanically and grow. But if you do that and your computer keeps growing like a termite mound, you can't have centrally controlled memory. You can't, because of bandwidth. And so every part of the structure as it grows has to carry its own memory, its own little local networks. And then there has to be some kind of a breathing mode, in or out or right or left. There has to be more global rhythms that then allow everybody to sync up. And it's fun because you take Dave Ackley's work and then you start pushing it beyond what he did, but to its logical limit, you start ending up with what looks like a living system. And so people worry about AGI actually coming into being. I honestly believe that it is possible with today's technology, something like that. But the first artificially intelligent systems will also be the first artificial life forms. Life and intelligence sort of come together. They're two sides of the same coin. So we might be able to make the first artificial mosquito, which I might be more afraid of than the Terminator robot. You think about it. What damage you could do with an AI mosquito.
I heard something really interesting the other day about that word intelligence. And I looked it up, and it's true. The root, if you get way down to the root of the word intelligence, it's the meaning of choose.
Mm-hmm. Oh, so I wasn't too far off then.
You weren't far off at all. That's exactly what it is. It's the choosing. I can't remember what the second part of it is, but it's choosing the proper, choosing the something like that, choosing the proper.
Okay.
But it's a choice. So your symphony of choices over time, that's
is a hat tip to was it Chris Petkow?
Petkow, yeah.
Yeah, that was his phrase. So I don't want to claim credit for it because that was his wonderful.
So one more question, and I don't want this to feel like I'm digging, but at one point you said, well, what it says is that Darwin wins. Why is that the automatic phrase? Because in order to be successful, we have to align with reality. Why does that imply? I can't think of the word. I'm getting tired. Why does that imply that Darwin wins?
I think so. I'm seeing things. There's two different levels to evolution. If evolution can be modeled as a computational process in itself, as a set of directed choices into the future, there must be a rule set that drives evolution that gets you past the combinatoric explosions. So if there's a rule set, there must be a language of evolution. And I've often wondered what that might be. But it's telling me there's evolution that's driven by conversation, which is what we're about. That's the kind of evolution that causes information to grow. People have noted that complexity grows.
But see, that wasn't Darwin's thought at all.
But no, that's not Darwin.
Yeah.
But I'm saying there's maybe two levels. There's a Darwinian version of evolution, which is just random guessing and we get it right, good to go. But then there's a separate layer of evolution, which is a rule-driven one, which we're a part of.
That requires a choosing agent.
Right? Yeah. So it's not either or, that as it always seems to boil down to in the arguments. That why can't we have both? Why can't we be seeing both happen? If you have one layer of complexity, then Darwin explores all the possibilities at one layer of complexity. But for a system to jump up and evolve to the next layer of complexity up, there has to be a rule set happening, a different layer. So maybe that's the way to think of it, is Darwin evolution explores a layer, a reducible layer in Wolfram's sense, whereas the choice or the language-driven, intelligent kind of evolution explores the levels up.
Well, someday I would really like to explore with an evolutionary biologist. One of the questions that I have is they always make the assumption that because of natural selection, that there was just unmitigated death and chaos everywhere of all these things that didn't quite make it dying. Mm-hmm. We don't see any evidence of that, physical evidence. Yeah. I mean, they have ways that they think about it that make them think that that's what happened. And that's partly why they say there must not be a God, because if there were a God, there wouldn't have been all this destruction in the whole evolutionary process. But if you start from a different assumption and think the way you're thinking, with this symphony of choices over time, and there's some sort of goal-directed thing, and there's some sort of rule set, then that makes of evolution an entirely different thing that would still fit with all of the evidence that's out there, that wouldn't require the death and destruction of this whole natural selection perspective. And it would make a whole lot more sense, because we don't actually see that all the weak get culled out of the herd, because very often the herd is very nurturing to the weak and helping them. So I just think that, yeah, if you have a different perspective on, so this is the whole thing about the observer, right? It depends on what question you're trying to answer. And if you have a certain question in mind that you want to get answered because you have a certain perspective, then you're going to observe what you're going to observe. And so, yeah,
there's so much seems to fall out of the computational way of thinking that I can't even, and it calls up it even questions space and time structure. If a choice is possible, I mean, choice only makes sense if there's options. And we talked about that means that each of these branches into the future path, there must be multiple future pathways which are still consistent with the past history of the universe. That's a flat out discontinuity in any mathematical sense. So that's telling you space-time is not continuous. Otherwise, there would be only one pathway into the future. So right off the bat, computation is hinting that space-time is not continuous. There's something else being out there. I noticed a lot of people are getting that. What is it? The last theory? What was his name? Mark Jeffrey?
Mark Jeffrey.
He's talking about it. Wolfram's talking about it. Nima Harkani Hamed's, he talks about the death of space-time. I think I've even picked up into it in some Jonathan Peugeot's conversations.
Well, Matthew Peugeot's book has got a lengthy section on space and time that's absolutely fascinating.
Yeah, so I think everyone's picking up on this notion that the fact that a conscious intelligence observer is telling you something about space-time, that's sitting there. So that's why I think the observer is a more important question than the anthropic principle, because it does force things onto you at the grunt physics level, which might blow a lot of.
Let me throw something else in here too. The other day I was listening to one of Arthur Holmes' lectures. He has this wonderful philosophy series. I'll put it in the link. And one of his lectures was on Whitehead. Now, I don't necessarily agree with everything Whitehead said. He had some strange perspectives, but one of the things that he was talking about that for him lined up with the Aristotelians, Socrates, Plato, and all those guys, the early guys, he was talking about possibilities as being something that actually exist in the same way that ideas exist. I guess is that I can't remember what version of philosophy that is. Is that realism or idealism? Anyway, but the idea, you know, that people who question whether math is discovered or invented, and some people feel it's discovered, that you're exploring mathematical space and then you see something and then you can bring that into our space. Well, he says that possibilities are like that. There is a possibility space and there are actual possibilities there that can be intuited or grasped and brought into our space. And that totally makes sense with what you're saying about that choice only makes sense if you have options. If options are available, means that they're like sitting there on a store shelf almost. And you get to choose one of them.
Yeah. Well, yeah, I can spin off on this one. That I talked about the computational irreducibility that Wolfram talks about. It seems to me it's more intuitive to understand if you think in terms of languages, that the languages that describe what's happening at one level of distributed intelligence can't describe what happens at the next emergent level. There's a group behaviors that happen that can't be described by the lower language. So there has to be a next layer up of language or grammar to describe what's happening up there. So if you just think in how if I come to a place when I can't describe, when words fail, you know, you often come to that point, that might be a hint that you're dealing with the next level up in life, or that's a hint that you're bumping into the transcendent, is when words fail. You can't just describe it in a nice recipe manner. But we get past that barrier by what we call archetypes. The archetype to me is a voice from above, the next layer of above coming down and showing us something. So like, is it Jonathan Peugeot? They're brothers, right? He's the one who does the icons. Well, art can be a form of archetype. It's giving you a hint about something else, next layer up, that's guiding us. You know, well, the meaning code. How do we get meaning? Its meaning is coming down from something above. And so the question is, how do we sense meaning at our layer? And there's all these little avenues. So you talk about anomaly, you know, which is a difference that makes a difference. We look out, we see something, and we go, huh, and it draws our attention. And in the process, all of a sudden we see or notice things that we hadn't noticed before. And that, I think, is one of the ways that we sense the transcendent layer above us. So
yeah, I really like that. I like the way you put that. I mean, Jordan Peterson always says that you meet the transcendent when you err, but it's not only when you err, not only when you make a mistake, but it's also when you bump into something that you can't understand, or when you bump into something that's a little bit threatening, or when you can't, like you said, when you can't articulate an idea that's coming to you. And I think this is how science makes progress, is that scientists have some intuition or something that they can't articulate, and it creates questions in their mind, and then they start to pursue it, and they go as far as they can with it, and then they bump into failure, or and that's where you meet the transcendent. That's the edge right there. And then later on you grasp something more and you keep going. So we're always testing the limits of where we end and where the transcendent begins, you know. So
yeah, and the opposite of transcendence is top-down causality, is what you get in strong emergence. Is somehow what's above us affects what's below. So I talked about the demon horde sort, Dave Ackley's work. So you have a program now running on an indefinitely scalable chunk of hardware underneath. The program can actually alter its own hardware now. So now this is a absolute perfect example of strong emergence, where what the cellular automata are doing can now actually rechange the underlying hardware to optimize for what the cellular automata are doing. So you can I don't know. I think that works both ways.
Yeah. Well, and for me, a much simpler thing for me to understand is just when you were talking about the different layers of language, I had two thoughts that popped into my head. One was that when I learned Japanese, you have to learn 4 different layers of grammar, because they have the grammar that you use when you speak of the emperor. It's a very exalted grammar. And then the grammar that you use when you speak of someone who is either your boss or your customer, it's a sort of exalted grammar. And then the grammar that you use when you're speaking laterally. And then there's a kind of degraded grammar that you use when you're speaking below you, like to a child or to a dog, which tells you they speak to dogs with the same language that you use for their children. But then there's the other sense in which there are layers of language, and that is that a child has their own language that they use amongst themselves, but they would never be able with that language to describe what their older siblings are doing. And the older siblings don't have the language to describe what their parents are doing. The parents often don't have the language to describe what the government is doing, you know? And so there are layers going up that way as well. And yeah, but the layers at the top have a power over the layers at the bottom. So so my language has a growth impact on my baby's language, right? So over time, their language grows because they're always in this learning process. So it's a top-down causality. Do you think we did it?
We're done. I'm done.
I'm done. Okay. This has been great, Glenn. I think it makes a great series, and I'm actually going to try to take the time to put it on a podcast, because I think people could really benefit from it, even in the podcast. Yeah. I got notified from Podbean, or one of these outfits that does stats for podcasts. I don't know how they picked up on it, but anyway, they said, "Good news, you are number 58 in science in Sweden."
Oh, I get those too.
I don't know how many podcasts there are in Sweden that are in science, probably 58. But I think it is valuable to put it into a podcast, because a lot of people like to listen and they can't always.
Yeah, that's what I always end up ripping your YouTube and turning it into MP3 so I can play it later.
Well, see, I have to be better about it takes extra time to put it on the podcast. And already it takes quite a bit of time to get timestamps and get the thing uploaded and all that stuff. So I do what I can, but it's been a delight to spend time with you, and I will let you get back to Robodog, and I'll quit bugging you with my question.
Okay, well, don't stop entirely, but but I think we've done it. I think I've covered all the ground that I've been thinking about for months, maybe since we started this conversations.
Yeah, well, very exciting. And I also want to point out to folks that when Glenn and I first started talking about physics and how physics relates to the origin of life, we were talking about finite state machines. Glenn introduced me to the concept of a finite state machine. And today there was a YouTube video on, I can't remember, it Reasons to Believe, and I'm going to put that in the comments. And he says he just realized as a biochemist that finite state machine is a good model to look at, considering a lot of biochemical processes. And I thought, Glenn told me that years ago. So I'm also going to put that series of yours and mine in the description for people who want to go back and watch.
Cool.
So thank you so much for your time and effort and all the time you put into making slides and all of that stuff.
Thank you. And especially your viewers and listeners for having stuck with me this long.
And don't we have a wonderful
So-
comment section? Their
Mhm.
comments are so deep.
Yeah, I apologize. I don't get to comments often, so maybe in the future I can. But I do as best I can.
Yeah. Sounds great. Thank you
All
so
right.
much, Glenn. Have a
Take care.
great day.
Bye.
Bye-bye.